Hello friends, how are you all? Welcome to my channel Chemistry Art. Myself Bhavik Patel, and friends, we are going to discuss today a balanced chemical equation. Last time we have already discussed that what is chemical reaction and how to write the chemical equation. Now today we are going to discuss how to write a balanced chemical equation or how to balance the chemical equation. So let's see first of all what is balanced chemical equation. An equation which is having the number of atoms of each element equal on both sides is known as a balanced chemical equation. It means that if you are having a chemical equation, for example here Fe plus H2O, it gives Fe2O3 plus H2. This is a chemical equation. So number of elements means here Fe iron, hydrogen, oxygen should be equal both the side, this side and this side. So this is not a balanced chemical equation. We can write this equation as a 3Fe plus 4H2O. It gives Fe3O4 plus 4H2. So we can write this equation like this, and then it is known as a balanced chemical equation. Why? Because you can see the number of atoms of each element are equal both the sides. Here 3 Fe, here Fe3 means 3 Fe are there both the side of arrow. Here hydrogen H2, but 4H2O is there, so this 4 will multiplied with this 2 and total 8 hydrogens are present in left hand side. Just like that, here H2 2 hydrogen, and here in coefficient 4 is there, so 4 2s are 8. Here also 8 hydrogen is there. Now just like that, here oxygen, nothing is written here, so here 1 oxygen, but into multiplied by 4, so oxygen are also 4, and here you can see that 4 oxygens are present. So this is called balanced chemical equation. Okay, so why we need to write the balanced chemical equation? Because the number of elements should be equal both the side, then and then the chemical equation will follow the law of conservation of mass. So see, total mass of elements present in reactant must be equal to the total mass of element present in a product. So it follows the law of conservation of mass, and you know that what is law of conservation of mass. Okay, in 9th you have already learned that the number of element if equal both the side, then and then the mass of element will be equal, and the law of conservation of mass is saying that mass neither can be created nor be destroyed. So whatever mass is present here left hand side, the total mass should be remain same right hand side, and it is only possible if your number of atoms of each element are equal both the side. Okay, so now I think you understood that what is balanced chemical equation and why we need to write a balanced chemical equation. Now see, unbalanced chemical equation, as I explained you, a number of atom of each element in reactant is not equal to the number of element of each element into the product, so it is called unbalanced equation, and this is unbalanced equation as we have already seen it. Unbalanced chemical equation is also called skeletal chemical equation, which is showing only the compound, means what are the reactant and what are the product, not how much mass both the side. Okay, so it is called unbalanced chemical equation. Now why a chemical equation should be balanced? So as already we have discussed that according to the law of conservation of mass, the total mass of product total mass of product must be equal to the total mass of reactant, and it is possible only if the number of atoms of each element is equal on the two sides of the equation. So then the chemical reaction or equation will be follow the law of conservation of mass, and we have to follow it. So we are writing a balanced chemical equation. So now friends, if you are having unbalanced chemical equation, so how will you convert into the balanced chemical equation? So let us see how to balance a chemical equation. You have to follow some steps. Here, first step, write the skeletal equation if word equation is given or equation is not given in terms of symbol and formula. Okay, so word equation means what? Instead of Fe you are given iron, instead of H2O you are given water. So it is known as a word equation, that iron is reacting with water or steam to give iron oxide or ferric oxide, then it is known as a word equation. So first of all, you have to write down in a symbolic form, whatever symbolic form is there, chemical equation like this you have to write down. And then after, first step, this is your first step, that enclose the formula in the boxes. This is very important. Why? First of all, you have to make boxes around the compounds. Why? Because it will say you that the changes should be outside of the box only. Okay, you cannot change inside of the box. Whatever you want to change, you have to write down here only in a coefficient outside of the box, because if you are changing after the compound or element, it will change the formula. So suppose Fe is there, you want to make 2Fe or 3Fe, so you have to write down here only that 2Fe or 3Fe. Okay, you cannot write after the symbol of Fe. For example, if H2O is there and you want to make 2 oxygen, so you can't write here, no, this is wrong, you can't write here, you have to write here, then this 2 will be multiplied with this oxygen as well as this hydrogen. So that's why we have to make box here. So you will be remember that you do not need to change inside of the box, always you have to change outside of the box. So this is first step, it is very important, you have to remember it. Okay, now second step. What is second step? So first of all, we have make boxes. Now in second step, you have to list out the number of atoms of different element on left hand side and right hand side of the chemical equation. One note is given here. See, during the balancing of chemical equation, no any change you can do inside of the box. So the formula of any reactant or product cannot be changed. I have already discussed that. So now what is second step? LHS left hand side and RHS right hand side. So first of all, make a small box. Whatever elements are there, separate them. For example, here, see, this is left hand side, right hand side, and we have written here the element. Here in left hand side, how many elements are there? Fe. So number of Fe, 1. Okay. Then H2O. In H2O, 1 oxygen and hydrogen. 2 hydrogens are there and 1 oxygen is there. So like this, you have to mention the number in left hand side and right hand side. Right hand side, you can see that 2 hydrogens are there. Here 2 hydrogen. Fe3O4. Here 3 Fe and 4 oxygen. So like this, you can classify them and identify them, that what is different of number of atoms. Okay, here you can see that 1 element, 3 elements, so this is unbalanced. Here 2 hydrogen, so hydrogen is already balanced, and here 1 and 4, so oxygen is not balanced. So like this you have to make a small box. Okay, now third step is very important, because whatever you have to do in third step only, select a bigger formula to start balancing. So in above reaction equation, here what is bigger formula? So Fe3O4 is a bigger, and so we will start to balance from this compound. Okay, as you can see that here in a previous slide, Fe, H and O hydrogens are already balanced. Fe here right hand side 3 Fe, and left hand side 1 Fe is there. Oxygen 4 and 1. So number of atom, which number of atoms are more? You can say that here 4 oxygens are there, so oxygens are more, and that's why we are starting with a bigger formula. So in that bigger formula the number of atom will be more. So we will start first of all oxygen and then after Fe. So start balancing oxygen. You can see here 4 oxygens are there, and here right hand side we wants to make 4 oxygen, so we have multiplied here 4. Okay, it was not 4 in previous slide, you can see that it was not 4. Okay, H2O was not 4H2O, but now after balancing the oxygen we can write 4H2O instead of any other number. So now you can see that the 4 into nothing is written here, 1 is there, so now oxygen are 4, so both the side oxygens are balanced. But due to this the hydrogen is unbalanced, because hydrogen number of atom of hydrogens are 2 and multiplied by 4, so hydrogen will be 8, and that's why we have to change over here also. Okay, so 2 hydrogens are already given, so what number we can multiply H2? If H2 is there, so what number we can multiply to make it 8? So we can multiply by 4. Okay, so we need to write down here 4H2, then the number of hydrogen will be balanced both the side. Okay, so like this you have to balance it. See the fourth step, to check correctness of the balance equation. After balancing oxygen, now check out which element number of atoms are changed, and if more atoms are remain unbalanced, then balance it one by one. So let's balance the Fe atom now. Okay, hydrogen we have already balanced. Okay, in previous slide we have seen that. See here 4H2 and here 4H2O, so hydrogens are balanced, oxygen also balanced. Now remain is Fe. You can see here 3 Fe are there, and here we have to balance, so we have written here 3, and now it is balanced. You can see in a previous slide that Fe here, Fe nothing is written here. Okay, whatever you have to write down here only, but here nothing is written, and to balance the Fe we have written here 3. So now this equation is balanced. And last step is checking the correctness of the balance equation. To make more informative, we can also write down state of, we can also add the state of the element. Okay, how we can write the state of element? So let me explain you. For example, Fe, what was there? Fe plus H2O, it gives Fe3O4 plus H2. So in which state they are present, we have to mention it. But how? If it is in solid state, you can write down as liquid, you can write out L, and if in a gaseous form, you can write down the G. So after the symbol you can write down all this as L or G in a bracket. For example, water is reacting in a gaseous form, so you have to write down here G. Fe is present in a solid form, so you will write down here S. Fe2O3 here in a solid form, so you will write down here S. Okay, and hydrogen in a gaseous form, so G. Okay, so like this you can write down and you can make it more informative. This is not a balanced chemical equation, as you know that you have to balance by writing here different numbers. Okay, so here 3Fe was there, here 4H2 was there, and here 4H2 is. So now I think you all are understood that what is balanced chemical equation and how to balance it. Okay, so let's see in my next video. I will show you more examples to balance the chemical equation. Thank you very much.